Today we're going to review what the distributive property is, look at how we combine like terms, and then how we solve two-step equation using these two skills. The first thing we're going to look at is we're going to look at how we can use the distributive property. And when we use the distributive property, we will distribute the number outside the parentheses to the parts that are inside the parentheses. So when we look at our first example, we're going to take this 4 that's outside of our parentheses and we're going to distribute that to the parts that are inside. So we're going to distribute it to the x and to the 3. The way that we're going to do that is we are going to multiply. And we know that we're multiplying because we have that number right next to our parentheses. So we can think in terms of that as being 4 times x as well as 4 times 3. And then that plus sign that's in the middle here is just going to drop down. We're going to keep that same operation. Notice that I have that 4 that was outside the parentheses is getting distributed to both the x and the 3 that were inside the parentheses. My next step then is going to be to solve these two sides. So 4 times x, we're going to rewrite that as 4x. And then our 4 times 3, when we multiply that, equals 12. And then again, that plus sign just comes down. So then my final answer, after I've done my distributive property, is 4x plus 12. So that is an equivalent expression to my 4 parenthesis x plus 3. We'll take a look at another example here with a negative outside. The same idea is going to work here though. We're going to take that negative 3 and we're going to distribute it so that we have negative 3 times our 2x and negative 3 times our 4. We're going to give that to both parts that are inside my parentheses. So looking at that first step again, I'm going to do the negative 3 times 2x, and I'm going to do the negative 3 times 4. And again, that plus sign is just going to come down and stay. Notice again that that negative 3 is being used twice in order to given to both parts of the things inside my parentheses. My next step then is to multiply these. So negative 3 times 2x will become negative 6x because negative 3 times 2 is negative 6 and then the x stays with it. And then negative 3 times 4 becomes negative 12. The plus sign will come down in the middle. So then my expression that is equivalent is going to be negative 6x plus negative 12. What I would like you to do now is try these two on your own. For the first one, we're going to distribute that negative 2 to both parts. That's going to become negative 2 times negative 2x plus negative 2 times 7. And then when I simplify and multiply those out, negative 2 times negative 2x becomes 4x, and negative 2 times positive 7 becomes negative 14. On my next one, I'm going to distribute that negative 6 to both the x and the minus 3. When I write that out, I'm going to end up with negative 6 times x minus, because this time I have a minus sign, and then I'm going to have negative 6 times 3. I'm going to put this negative 6 in parentheses only because I have that minus and that negative sign. Then when I start to multiply, negative 6 times x is going to become negative 6x. I'm going to keep my minus sign, so that's going to drop down. And then negative 6 times 3 is negative 18. I'm again going to put that in parentheses. That expression is equivalent, but I could also take it one step further, and I could take the minus and the negative, and that's going to become a positive, and I can rewrite it as negative 6x plus 18. So both of these answers represent equivalent expressions to our distributive property. Either one of those would work. Next, we're going to take a look at combining like terms. When we combine like terms, we are combining the parts that are the same. Numbers by themselves can be combined with other numbers by themselves, and variables can be combined with the same variable, meaning that x and x can be combined, or y and y can be combined. A y variable and an x variable cannot be combined. In these problems, I like color coding to make sure that we're keeping track of our parts. So I'm going to start by, in our first example, color coding my two terms or parts that have an x. Then I have the 7 that is separate. That's a number by itself. That color looks similar. Let me change that. So then when I'm combining my like terms, I can combine the things that I've highlighted the same color. So the two parts with the x, I can combine those. When I combine those, I'm going to use that operation that's in the middle, and I'm going to think that 4x plus 5x will become 9x. I'm going to add the numbers in front of that variable together because I have a plus sign in the middle. Since I only have one part that is highlighted in green as just the number by itself, there's nothing for me to combine that to. I'm just going to bring that down as a minus 7. So once I've combined like terms, my equivalent expression is now 9x minus 7. My two parts with my x's have combined. The negative 7 comes down alone. When I look at the second example, I'm going to again color code. So I'm going to color code the parts with the variable x. And this time, because they're separated, and I could have done it on the first one, I'm going to highlight that operation that's seen in front as well, because that's going to be helpful when I go through. So I have a negative or a minus 2x, and I have a plus 6x. Since both of those have the variable x, those are common terms. And then I'm going to highlight my numbers that are by themselves, which would be just the 3 and then the plus 8. So now I'm going to think about how I combine those parts that I've color coded. So looking at our parts with our variable first, I'm going to think in terms of taking the minus 2x and plus 6x. And when I combine those, a negative 2 plus 6 is going to become a positive 4x. When I look at my numbers by themselves, there I have a 3 and a plus 8, and when I combine those, that becomes a positive 11. So then I'm going to put plus 11 because it's positive. So then my equivalent expression after I've combined my like terms will end up being 4x plus 11. At this time, try the two below on your own. Okay, I'm going to again highlight and color code as we go over this. So I have the plus 12x and I have the minus 5x as my two parts with my variable. And then for my numbers by themselves, I have a negative 7 and a plus 4. When I combine my parts with my variable, that's a positive 12x minus 5x. So then when I combine that, that's going to become 12x or 12 minus 5. So that becomes 7x. When I look at my numbers by themselves, I have a negative 7 plus 4. And so when I combine that, it becomes a negative 3 because negative 7 plus 4 is negative 3. So then my equivalent expression is 7x minus 3. Looking at this last one, I notice that I have two different variables. So I'm going to add another color in for my highlighting to separate my different parts. I have a plus 3x and a plus 8x. Then I have my 5 and my minus 4. And then the last one I have as a new part is my negative 2y. So notice now I have three different colors because I have three different types of parts. So I'm going to start by combining my parts with the x. So I have 3x plus 8x, and 3 plus 8 becomes 11x. Then I have my parts with my numbers. So I have the 5 minus 4. And when I solve that, that becomes a positive 1. So then I'm going to put plus 1. And then my last part I have as a negative 2y, and I have nothing else to combine that with. So that I'm just going to bring down, and I have minus 2y. I'm going to add my little caret in here so that we can see. So 3x plus 8x came my 11x. 5 minus 4 was my plus 1. And then that minus 2y just comes down because there's nothing else to combine it with.